All right, hello you guys. So I am going to go ahead and record a voiceover of me talking through our experimental design slides. The reason I'm doing that is because there are some concepts in here that I know are tricky the first time you hear them. So I'm hoping that being able to hear me talk about it rather than just reading what I was writing will be helpful for you guys. So we'll see how this goes. I'd love to hear your feedback when you finish this week's module. Especially about whether you would like me to do this for the next couple weeks as well, or whether you'd like me to go back to what I was doing before with the slides, with the notes that has my little script in there. So let me know what you think about that. All right, so here's our agenda for these slides. We're going to talk about experimental variables. We'll talk about establishing causation. We'll talk about independent groups versus within groups designs. We'll talk a little bit about interrogating causal claims. And then we'll talk about what's going to be next in our course. All right, so let's start with experimental variables. All right, so as you know from the reading that you just did for this course, for this module, by the way, if you haven't done the homeworks for this module, you're going to get more out of this if you do the homeworks first. So if that's the case for you, go ahead and pause this video, go do the homeworks, and then come back. But in the readings, you read about how there are many different ways that we can classify experimental variables. So we can classify them as measured versus manipulated. We've talked a little bit about that before. So what does it mean for a variable to be manipulated? What does it mean for a variable to be measured? Now, if we were face-to-face, I would call on people to answer these. Obviously, I can't really do that here. What I recommend you do is pause the video for a second, come up with your answer, say it out loud, because remember when we talked in metacognition, we talked about that teach the material strategy. You don't have to have another person present for you to try that. I recommend as we go through these slides, there'll be a couple slides like this. Each time I recommend that you pause the video, give an explanation out loud, even if it's just to your computer or an empty chair in your room. And then you can play the video and hear the explanation that I'm going to give, and you can kind of check yourself to see how well you're understanding it. So go ahead and pause the video for a sec. I'll give you a second to pause it. All right, hopefully you have done your verbal explanation of this concept. So let's talk about what that means, right? For a variable to be manipulated, that means that the researcher is messing with it. So if I'm the researcher, I'm doing a study. If I'm going to manipulate a variable, I'm going to tinker with it. So I'm going to assign people to be in different conditions of my variable, right? That's the cause and my cause and effect. I'm going to mess with that. And then if a variable is measured, as the researcher, I'm not messing with that at all. So I'm not touching it. I'm not varying it between my participants. I'm just giving everybody the same exact measurement. And then I'll use that to see if whatever I manipulated had an effect on whatever I think it's going to have an effect on. So if, for example, I was trying to find out the whether feedback type changes people's moods. So say I think that giving people negative feedback, oh, here's my cat, giving people negative feedback, maybe I think that that's going to make them unhappy, right? And giving positive feedback, maybe I think that'll make people happy. So in that case, I think feedback is going to cause a change on mood. So feedback should be my manipulated variable, mood should be my measured variable. In that example, I would manipulate mood by giving different participants different feedback. So I'd give some people positive feedback, I'd give some people negative feedback. And we would do that we would do that, I'm distracted by my cat. We would do that by choosing, right, random assignment. You read about random assignment in your textbook. Some people would be put in the positive feedback condition, some in the negative feedback. Maybe I would have them all write me a little essay, and then I would randomly assign them to get feedback that says, wow, your essay was awesome, or wow, your essay totally sucked. Now that would be manipulated, right? I'm not actually judging their essay. I'm just randomly choosing who gets positive and negative feedback. I'm tampering with that, right? I'm giving them positive or negative feedback. That's manipulated. And in that example, the measured variable would be mood. So after I give them that, manipulated feedback of positive or negative, then I would give everybody a mood scale and I would measure what their responses are. Now, importantly, in that mood scale, that measured variable, I'm not messing with that. So I'm not giving people different mood scales, right? Everybody's getting the exact same mood scale, no matter what condition they're in, because then at the end of the study, I'm going to do an analysis, some statistical analysis, to see is the feedback type that I gave people, is that affecting their mood? And for that comparison to work, everybody has to have the same measured variable, even though they're getting different experiences in the manipulated variable. All right, so that's measured or manipulated. We talked about that a couple times before. All right, here's going to be the first activity. So this is activity number 1 for this week's module. There's a list of variables here, and your job is to decide whether you think they'd be measured or manipulated. So A, participant's age; B, number of siblings; C, how long participant given to complete a task, 30, 20, or 10 minutes, how long participant takes, right? All this good stuff. So for each of these variables that's given here, your job is to determine whether you think it's a measured variable or a manipulated variable. Now for this activity, if you just put numbers A through K and then you write measured or manipulated, that's totally fine. But if you'd like to get a little more benefit from this activity, I recommend put whether it's measured or manipulated, and then just write a little bit, like maybe a sentence that explains why you think that'd be measured or manipulated. Remember, that's that teach the material strategy. Even if you're not verbally saying it out loud, the act of giving that explanation for this activity is going to help you practice those concepts more. All right, so same drill as usual for these activities. Your job is to pull up a Word document, write your answers on there, and then you're going to go ahead and submit that to the activity number 1 submission portal for this week's module. So if you need to take a minute, pause the video, complete this activity before you go on, that'd probably be the most helpful. All right, so once you're ready, once you've got that activity done, remember I'm going to post the key for that next week. Once you've got that done and submitted, let's go ahead and continue on. All right, so we've got the measured versus manipulated, that way of classifying experimental variables. We can also classify experimental variables as independent or dependent. And we have talked about this before in a couple of previous classes, but here's where it's really important. Experimental design is where independent variables and dependent variables are incredibly important. All right, so a couple questions here. In a cause and effect relationship, which is the IV and which is the DV? Is the IV measured or manipulated? Is the DV measured or manipulated? So take a second, right? Again, I recommend pause the video, explain what you would say, what your answer to this would be out loud. Again, gives you good practice with practicing those concepts. Once you have taken a minute to explain this out loud, go ahead and start the video again, and you'll hear my explanation. You can compare it to your own. All right, so in a cause and effect relationship, the IV is manipulated, the DV is measured. So the independent variable, that's the one that the researcher is tampering with, the researcher is manipulating. That's the cause in the cause and effect relationship. The DV is measured, so the DV is the effect in the cause and effect relationship. If we were going to use that example from previously of feedback type and mood, feedback type would be the IV, that's the one that I as the researcher am manipulating. So feedback type is the IV. The DV in that case would be mood. That's the one that I'm just measuring. It's the one that I think is going to show some kind of an effect based on my manipulation of feedback type. So IVs are always manipulated, DVs are always measured. Excuse me, okay. There's another thing that we can talk about here with experimental variables, and that's what we might call control variables. Now this term is actually specific to this textbook. I've never really heard them called control variables in other contexts, so you might not hear it phrased this way in your future classes, but control variables are something that we can think about with experiments. So I want you to think about why it's important to have control variables. So if you need to quickly refresh yourself on what control variables are, maybe start with that. Then pause the video, take a second, and explain out loud what's the point, what's the purpose of having control variables when we're doing an experimental study. All right, so it's important to have control variables. These are variables that you're actually holding constant. So these are things that you are not varying in your experimental study. It's things that you're holding constant. It's important to have control variables because in order to make a cause and effect claim, which is what we want to do with experimental design, I don't know if you can see here. My other cat is getting some scritches in. That's Frank, he's my white cat. My calico cat is Caterpillar. You'll probably see them a couple more times in this video. They're really excited that I'm home all the time. All right, so it's important to have control variables because in an experimental design, what you need to do is make sure that your independent variable is what's impacting your dependent variable. That's internal validity. We've talked about that a couple times before, right? We need to make sure that our X is really causing Y, our IV is really causing our DV. It's really feedback type that's causing mood, for example. That's the whole point of internal validity, and that's the whole point of an experimental study, is to make a cause and effect claim, to make a causal claim, right? So control variables, that's where you're holding everything else constant, everything else except the IV. Because you only want your IV to be varying between your two conditions, right? In this feedback and mood study, for example. If something else is also varying, that's a big problem because it means you might not be able to actually make a causal claim. So for example, in that feedback and mood study, say that I didn't randomly assign my participants and all of my female participants ended up in my positive feedback condition and all of my male participants ended up in my negative feedback condition. And then maybe I find that my positive feedback condition, those participants are in a better mood than my negative feedback condition. I have a problem now because I have something else that could be an alternate explanation for that finding. Maybe it's feedback that caused a change in mood, or maybe it's gender. Maybe women are just generally in a better mood than men. Because I have this other thing that's varying, in this case gender, I didn't control that, right? In that case, that now I have a threat to my internal validity. Now there's some other explanation for why I might have gotten the findings I got. So it's really important when you're doing an experimental study that only your IV is altering or is manipulated or is changing between your multiple conditions. So when you don't have control variables, right, you're not making sure everything else is staying the same, like I'm not making sure I have even distribution of gender across my conditions, that becomes a big problem. So how do control variables help establish causation? I kind of already talked about this, but still good practice for you to pause the video, give a verbal explanation out loud, and then restart it. All right, so control variables help establish causation because it helps improve internal validity. If you're keeping everything else constant other than the IV, then you have much more ground from which you can say, yeah, it really is my IV causing changes in my DV. It's not something else. There are no alternate explanations. It's just the IV causing the DV. So that's, again, it's an internal validity question. So by having control variables, by keeping everything else constant other than the IV, that's helping you a lot to make that causal claim. Now, one thing that I think we've talked about before is that in experimental design, right, causal claims, the whole point is to establish cause and effect, right? That's the purpose of this type of study. And this is where it's really important to have good internal validity, because if you don't have good internal validity, if you have a threat, like you have something that you didn't control that you should have, that just invalidates your entire study. In an experimental study, if you have poor internal validity, you cannot make a causal claim. And that's a huge problem because, again, the whole point of an experimental study is to make a causal claim. I think we're going to talk more about this in just a second. All right, yes, here we go. Establishing causation. All right, there are 3 criteria to establish causation. We've seen these before in previous chapters: covariance, temporal precedence, and internal validity. Those are 3 things that you need to have in order to make a causal claim. If you don't have even one of these, like say you don't have temporal precedence, you cannot make a causal claim. Your whole study is invalid, right? And you've just wasted, whatever your study was. All right, before we get into this question, I want you to think for a minute about what covariance means, what temporal precedence means, and what internal validity means. So pause the video, give a verbal explanation, then come back. All right, so covariance means that there's a relationship between your IV and DV. So for example, feedback type and mood should be associated in some way. They should be varying together. That's what covariance means, varying together, have a relationship. If feedback has nothing to do with mood, then I can't make a claim that feedback affects mood, right? I just can't do that. So I have to have covariance. So that's covariance. They have to be related, but that's not enough, right? Just having covariance would give you enough for an association claim that they are related to each other, but covariance alone is not enough for causation. You also need temporal precedence and internal validity. Temporal precedence is that your IV has to come before your DV. If I'm doing that feedback type and mood study and I do the mood measurement and then I manipulate feedback, you can see the problem, right? I can't possibly say that feedback caused mood if I measured mood before I gave the feedback manipulation. That becomes a big problem. Temporal precedence is a big issue sometimes when researchers are doing a correlational study and then a journalist makes a causal claim. Like we had an example way earlier in this semester. It was something like pressure to be online 24/7 is causing teen anxiety. But in reality, they just measured those two things. So they measured how much people felt pressure to be online all the time and how anxious they were. And so if you're just measuring them, you can show covariance, right, that they're related to each other. But if you're just measuring them, you can't show temporal precedence. You don't know if pressure to be online came first and then caused anxiety, or maybe anxiety came first and then caused pressure to be online, right? That's an issue of temporal precedence. Now, when you're doing a true experiment, you're manipulating an IV, measuring a DV, you always have to manipulate the IV first and then measure the DV. As long as you do it in that order, you have temporal precedence. So that's part of the purpose of manipulating the IV. It's ensuring that you have temporal precedence, that your IV is coming before you're measuring your DV. So you have to have covariance, they have to be related to each other. You have to have temporal precedence. IV has to come before DV. And then internal validity, right? That's about making sure there aren't any other possible explanations. Like we just talked in the last slide about the feedback type and mood study. If I have gender, right, as a sort of a variable that's also varying between my conditions, all women in my positive feedback condition, all men in my negative feedback condition, now I have a threat to my internal validity. I have an alternate explanation, a possible alternate explanation. Is it feedback type that causes mood changes, or is it gender that's causing that difference in mood? In that example, I don't know anymore, so I have a big internal validity problem. So even if you have covariance and temporal precedence, if you don't have internal validity, in other words, if you have a threat to your causation, your cause and effect, IV to DV, that again invalidates your study. All right, so here's this question that's on the slide here. How can comparison groups help show covariance in experiments? Take a second, think on your own, give that verbal explanation, then restart the video. All right, so comparison groups, we talked about this way at the beginning of the semester. We talked about this because when you have just your personal experience, right, that's lacking a comparison group. You don't know what would have happened if you had done things differently because you only have your own experience, right? So comparison groups help you assess what the effect would be if you did something differently. Like in the feedback type and mood study, right? If every time you get positive feedback, you feel great, but that's the only kind of feedback you've ever gotten, you wouldn't know how negative feedback would make you feel. So that's the point of having a comparison group, to say, okay, here's what happens when you get positive feedback, here's what happens when you get negative feedback, here's the difference between those two. So it helps us to show covariance in experiments. If you just give positive feedback, right, and then you measure mood, you have a hard time saying for sure what's really going on there. It's adding that comparison group that helps you show what's the difference between them. If you gave positive feedback or negative feedback and it had no effect on mood, so mood was the same, then you would see that there's not really covariance there. Feedback's not associated with mood because mood would be the same no matter what kind of feedback you gave. Now, we all know from our own lives that that's not what would really happen with that study, but say it did, right? Then that would show you that you don't really have covariance between those two variables like you thought you did. All right, and then next, why is temporal precedence important when testing cause and effect? Take a minute, pause the video, give your verbal explanation out loud, and then come back. All right, so temporal precedence, right? That's that idea that your IV has to come before your DV. And that's really, really important because you need to know that your IV came first if you're going to make a cause and effect claim. Again, if you gave a mood scale first and then you manipulated feedback type, you can't possibly say that feedback affects mood because mood came first. Or again, that example, if you're just measuring two variables, so you're not manipulating either, just measuring them both, like pressure to be online all the time and anxiety, right? You don't know which one came first. You can't make that cause and effect claim. So temporal precedence is really important in establishing causation. It's a really important piece. All right, lastly here, what are design confounds? This is a term from the reading and something we've talked about way at the beginning of the semester. So take a minute, think about this, give your verbal explanation, then restart the video. All right, what are design confounds? So design confounds, these are alternate explanations that are kind of built into your study. So it's other variables that you didn't control for, they weren't control variables, right? That are varying alongside your IV. So not just feedback type that's varying, but for example, gender in this case would be a design confound, that example from earlier. It's something else that could be an alternate explanation. And again, that's a big threat to internal validity. And if you have a threat to internal validity like that, then you're not able to make that cause and effect claim, which again is the whole point of an experimental study. All right, so something that was in the textbook, this is a point that people are often confused about. So this is part of why I did this as a voiceover for these slides. This is this idea of systematic variability and unsystematic variability. Now, first off, let's break down what these terms mean. Variability, that's changing, right? So things that are changing. Systematic variability, that's something that's changing in a systematic way, versus unsystematic variability is changing unsystematically. And I'm going to talk you through a couple examples of this. But from your textbook, you read about how systematic variability is a threat to internal validity. It creates an alternate explanation for our results. Unsystematic variability is not a threat to internal validity. It does not create an alternate explanation. Unsystematic variability is what we expect. So when we do research, we always expect unsystematic variability. We account for that in our calculations and our statistical tests. But systematic variability, that's a problem. All right, so let me talk you through what fixes this problem, and then I'll talk you through an example of this. So random assignment, as you read about in your book, that takes care of problems with unsystematic variability. Random assignment is when you're randomly assigning people to your condition. So in my feedback and mood study example, random assignment would be that I would, take all of my participants who are in my sample, and I would maybe draw names from a hat or draw numbers from a hat to decide which condition they're in. Something that randomly puts them in one of those two conditions of positive or negative feedback. The reason that's a really important part of the process, and it's because it gets rid of these problems with unsystematic variability. Now I'm going to talk you through this using the example of the pasta bowl study that you read about in your textbook. So in this study, what the researchers did is they gave people the option to eat pasta from either a medium bowl or a large bowl, and then they measured how much pasta did they eat or did they serve themselves. You can see on the top of this graphic on this slide here, I took this right from the textbook, that the pink bar on the left-hand side, that's the medium bowl, that's how much they ate from the medium bowl, and then the blue bar on the right-hand side, that's how much people ate from the large bowl. You'll notice from this graph, right, the y-axis is pasta served, higher numbers mean more serving. So the people in the large bowl, they ate more pasta than the medium bowl. It's an interesting finding, right, that the size of the dish you're eating from might impact your eating habits. Most people would think now that doesn't matter, but this research shows that, yeah, actually it probably is, part of what's going on when you decide how much you want to eat when you're eating pasta in this example. Now, what's important about this, right, the IV in this study is the bowl size, medium or large. The DV is how much pasta they ate, right? So the IV, the bowl size is manipulated. The researchers randomly assign people to conditions of either medium or large bowl. And the reason they did that is to get rid of self-selection problems. If I say I was running this study and I put out a medium or a large bowl and I told my participants, here's a medium bowl, here's a large bowl, choose which one you want and then go serve yourself. Now I have a huge problem with my findings because I don't know if it's the bowl size or something else that's causing a difference in what they're eating. Put yourself in the shoes of a participant in this study, this hypothetical version that I'm doing where I let people choose. If you are really hungry when you're doing this experiment, which bowl size are you going to choose? Maybe you can choose a large bowl. If you just ate lunch and you're not very hungry, you might choose a medium bowl, right? If you really love pasta and spaghetti, maybe you choose a large bowl. You're like, yeah, man, I want a lot of spaghetti. But if you're like not a pasta fan, you might choose the medium bowl. Like, I don't want that much. So you see, this is creating alternate explanations for our findings. We find in this study, in this graph here, that the people with the large bowl ate more than the medium. But if I let people self-select which bowl they wanted, maybe all of my pasta lovers and hungry people choose the large bowl and they eat a lot because they love pasta and they're hungry. And then my people who don't love pasta and who are full or have already ate maybe choose the medium bowl and they don't eat very much. Now it's not really the bowl size that's causing this difference. You see what I mean? It's not the bowl size anymore. It's the people's characteristics, whether they want pasta, whether they like pasta, whether they already ate or are hungry. That's what's really causing that difference. That's a confound in this version, my hypothetical version of the study. It creates a design confound, self-selection. I think we'll talk more about that idea later too. But it creates an alternate explanation. That creates a threat to internal validity. I'm trying to say that it's the bowl size that changes how people eat, that the bowl size is the real cause in that cause and effect link. But in reality, because I let people self-select, I don't know if it really is bowl size. Maybe it's just how much you like pasta determines how much pasta you eat. That seems logical, right? Or how hungry you are determines how much pasta you eat. So again, not bowl size, but it's how hungry or how much you like pasta. That's the real reason. That's the alternate explanation. That invalidates the cause and effect link I'm trying to give information about with bowl size. That's systematic variability. So this term systematic variability, right? Variability we expect, variability in the DV, in this case, variability in pasta serving. We expect variability. Not everyone's going to take exactly the same amount, right, no matter what. But if people are self-selecting a bowl size, then their personal characteristics, like whether they like pasta or whether they're hungry or not, that creates systematic variability. So there are different types of people in my two conditions. That might be the easiest way to think about this. Systematic variability, that's when you have different types of people in your two conditions, or they're having different types of experiences. So it's not the bowl size that matters anymore in this hypothetical example. It's these other characteristics that caused them to choose the larger or smaller bowl. So the larger or smaller bowl didn't change what they were doing. There are other characteristics, like whether they are hungry, that created the difference. All right, here's my cat again. So that's why systematic variability is a problem. Now let's talk about unsystematic variability. I mentioned earlier that we always expect variability when we're doing research. We know that people are not identical robots, right? Everybody who comes to this study is going to have different experiences. You can see in the graphic here on the bottom side, this is showing you the unsystematic variability that we would expect in this study if they are randomly assigned to condition. So now we're going to switch back from my hypothetical version. Now we're talking about the original study where they randomly assigned people to only get a medium or a large bowl. They didn't even know that bowl size was being manipulated. They only got a bowl and they got pasta and they ate from it. They had no idea that other people were getting a different sized bowl. So you can see here all these little people in these two conditions under the medium bowl and the large bowl. You can see that they all have different characteristics, right? If we look at the medium bowl, little graphic on the far left side, somebody didn't eat breakfast, somebody loves pasta, somebody's gluten-free, somebody hates pasta, somebody's dieting, somebody's a big eater. All of that is unsystematic variability, right? You get that same mix of people in the medium bowl condition as you have in the large bowl condition. Some people love pasta, some people are light eaters, some people are athletes, some people are dieting, right? That same mix of people is happening in both of your conditions. That means it's the same type of person in both conditions. You don't have anything systematically changing, right? If somebody is in this study and loves pasta, they had an equal chance to be in either the medium bowl or the large bowl condition. So you see it's getting rid of that self-selection. It's distributing these characteristics across our two conditions. So we know these characteristics are going to vary among people. That's unsystematic variability. Just like how if you were in this study, right, everybody in our class was in this study. Some people in our class love pasta. Some people in our class are light eaters, right, or big eaters. And so if we were to randomly assign everyone in our class to this study, we would distribute those characteristics equally between those two conditions. So random assignment, right, distributes individual differences across those conditions. It means that we are only dealing with unsystematic variability because we have some pasta lovers in both conditions. We have some people who are really full already in both conditions. Some people who are, hate pasta in both conditions. Some people who are dieting in both conditions, right? We have the same type of people in both conditions. That creates unsystematic variability. It's just variability in the responses. So all of these little people in this graphic here, they're going to eat different amounts of pasta, right? We know that. They're not all going to take the exact same amount. But when we average out between both of our conditions, on average, how much do people eat in the medium bowl condition? On average, how much do they eat in the large bowl condition? That's what creates that graph you see at the top of the screen there, the medium bowl, large bowl, the pink bar, blue bar. That averaging out, right, that's what creates that graph. So we know that there's unsystematic variability. That graph isn't showing exactly what every single person does. It's just the average of what the people in those conditions do. So we know that unsystematic variability is going to happen. That's fine. We actually account for that when we're doing our statistical tests. That's part of the calculation process in statistics, is the variability that we expect. So unsystematic variability is fine. It's systematic variability that's the problem. So again, that would be like my first example on this slide. If I did a version of this study and I let people choose whether they wanted medium bowl or large bowl, and all my pasta lovers and people who are hungry picked a large bowl and eat a lot, all my pasta haters and people who are full choose the medium bowl and they eat very little, that's systematic variability. It's not the bowl that's causing this effect anymore in that example. Now it's the type of person, because I have different types of people in my two conditions. So if I have different types of people in my conditions, that's systematic variability, that's a problem. That's like my earlier example with the feedback type. If I have men in one condition, women in another, different types of people in my conditions, that creates a problem. But if I have the same types of people in my two conditions, like the distribution in this example of pasta lovers and pasta haters, or in the feedback type and mood example, if I have men and women distributed equally across those conditions, same type of people in those conditions, then I can really see what is the IV doing. So in this case, what is bowl size doing? Or in my other example, what is feedback type doing? All right, I know that's a little tricky to get your mind around. The nice thing about this being in a video format is if you'd like to go back and listen to me explain this again, you can do that. So I recommend if you're still a little confused, try listening to this again. And then if you're still confused, maybe you'd like me to give you another example of this, you can always put this in your exit ticket Monday point, and I can recap it in next week's module. All right, here's a bonus activity. Now, this is not worth points. It's not worth extra credit or anything. It's just a bonus activity. If you would like a little more practice with this week's concepts, you're welcome to complete this activity. It's nice practice, right? If you'd like a little extra time to work with these. I'm not planning on posting a key to this because I don't know how many people are going to do this bonus activity. So I recommend if you do complete this bonus activity, there's a couple others in this set of slides as well. If you do complete this bonus activity, go ahead and email it to me and I can give you feedback on your responses. I think that's the most direct way to do this. All right, this is another bonus activity. Same idea here. It's not worth points, but it's nice to have a little extra practice. If you do complete this activity, go ahead and email it to me and I can give you feedback on it. All right, now let's talk about independent groups versus within groups designs. Now we're getting into the second part of the homework, right? The first part was homework number 13. Now this and the rest of the slides are for homework number 14. Excuse me. Okay, so independent groups designs, we'll talk about these first. This is where different groups of participants are in the different levels or conditions of the independent variable. So for example, if I'm doing that feedback type and mood study, if I'm doing it as an independent groups design, then I'm going to take all of my participants, I'm going to put half of them randomly. I'm going to put half of them in the positive feedback type condition, put the other half of them in the negative feedback type condition, and then that's it. They get the feedback type, they provide their mood, and then I assess what's happening there. So different groups of participants in the different levels. They only see one condition. That's also like in the pasta bowl example that we were just talking about. If I am going to do independent groups, then some people are going to get a medium bowl, some people are going to get a large bowl, and they're not going to know that there was any other condition. So different people in my different conditions. It's independent groups design. All right, there are two major types of independent groups designs. There's the post-test only design and there's the pre-test post-test design. Both of these are actually pretty common in psychology research. So post-test only, that is where you're giving your independent variable and then you're just doing your post-test. Your post-test being, you can only get the DV once, right? So that'd be like the pasta bowl study. You give them the bowl type, either medium or large, and then you see how much pasta they eat. That's your DV. So post-test only. Pre-test post-test is where you're going to give the DV twice. You give the DV first, then you do the manipulation, then you do the DV again. In the pasta bowl study, that would be like if I gave people the pasta to eat first, and then I gave them a bowl type, medium or large, and then I gave them the pasta to eat again. You can see why that would be a disadvantage in that type of study, because they'd already be full from the pretest. But a study where this would work better is the feedback type and mood example. In this pretest post-test, if I was going to do this pretest post-test, I would give people a mood measure first before I did anything else. Then I would give them positive or negative feedback. And then I'd give them a mood measure again. And in that case, I can look for change from pretest to post-test. And that could be valuable for me to see, is if they get positive feedback, is it increasing their mood from the pretest? If they get negative feedback, is it decreasing their mood from the pretest? Right? Pretest, post-test lets me check that. And in that feedback type and mood example, that would be fine. But in the possible example, pretest, post-test would not make sense, right? Because then they'd be full from the pretest. So both of these are common in psych research, but there are specific times where either of them would be a better decision. All right, now within groups designs are different from independent groups designs because in within groups designs, participants are experiencing all levels or conditions of the IV. So independent groups, they only see one condition. They don't even know that other conditions existed. But in within groups, people are seeing everything. So this would be like if I have participants come to the lab and I'm doing the postable study and maybe I first give them a medium bowl and I say, okay, here you go, go eat whatever pasta amount you want. Then they go eat that and they come back and say, okay, here's the large bowl, now go eat whatever amount you want. They eat it and they come back. Or in the feedback and mood type example, that would be like I gave all my participants positive feedback first, check their mood, and then I have them write a second essay, give them all negative feedback, and then check their mood. Right, so they're experiencing both conditions, one after the other. Now, within groups designs, there are really big pros and cons to this type of design. So huge advantages and huge disadvantages. The advantages to this is that it increases your power and decreases the effect of individual differences. So power is a statistical concept. It's your ability to detect a real effect if there is one. When you're using within groups designs, you don't need as many participants in order to detect a real effect because they're in all conditions of your IV. And it decreases the effect of individual differences because it's getting rid of more of that unsystematic variability. Right? If you are in independent groups designs, right, some people are pasta lovers or haters in either condition. But if you're doing within groups designs for the postable study, the pasta hater is going to eat from both the medium bowl and the large bowl. The pasta lover is going to eat from both the medium bowl and the large bowl, right? You're getting rid of that individual difference. Each person is acting as their own control. That's a term you might hear when we're talking about within groups designs. So that can be a good thing. It means you need fewer participants and you have less unsystematic variability. But there are problems with that too, right? It takes a lot more effort to minimize order effects. So order effects you read about, that's where the order, whichever condition they experience first, has an effect on the DV. So if I was going to do that postable study as within groups designs, I give everybody the medium bowl first, they go eat. Give everybody the large bowl next, and then they go eat, right? What do you think is going to happen? They're all going to be pretty full from the medium bowl, so they're not going to eat that much in the large bowl. But it's not because of the bowl size, it's because they already ate stuff from the first condition they took part in. So minimizing order effects, that's where you do things like counterbalancing. So with counterbalancing, some people are going to get medium bowl first and then large bowl. The other people are going to get large bowl first and then medium bowl. So that helps to minimize those order effects. You can read more about that in your textbook. And demand characteristics are a problem too. If participants are seeing both of the conditions, they know what it is that you're studying. Imagine that you're a participant in my feedback type and mood study. I have you write an essay. I give you positive feedback. I say, wow, what a great essay. And then I give you a mood scale. And then I have you write a second essay. I give you negative feedback. I say, wow, this essay sucked. And then I give you a mood scale. You're going to know what I'm studying, right? You're going to know that I'm looking to see what feedback does to mood. Whereas if this was independent groups and you had only seen one type of feedback, you would have no reason to doubt that I'm just giving you legit feedback and you wouldn't maybe know what it was that I was studying. So that's demand characteristics. Participants are on to you. They know what it is that you're doing, and they might change their responses, not give you natural responses. If you're a participant and you know what I'm studying, you might say, oh yeah, that's reasonable. I'm going to make sure that result gets supported when I alter my data. Or you might say, that's crap, I don't like what you're doing, I'm going to give really bad data on purpose, right? Those are demand characteristic issues. There's things that we have to worry about when we're doing psychological research. So within groups designs, really big advantages, but also big disadvantages. So like a lot of research methods in psychology, there's no one correct answer to whether you should do an independent groups or a dependent groups, or sorry, an independent groups or a within groups design. There's no right answer, right? There are pros and cons to both, and you have to decide which one you think is more appropriate based on what kind of a study you are designing. All right, so here's activity number 2. So same idea as the last one. Grab a new document, write down your answers here. I will be posting the key to this next week. So go ahead and jot down your answers to this, pause the video, and then submit it, and then come back when you are ready to continue. All right, now last but not least, let's talk a little bit about interrogating causal claims, and then we will wrap up for this week. All right, so we're going to talk a little bit about interrogating causal claims again, and then we're going to wrap up for the day. So when you're interrogating causal claims, you're asking questions about those 4 big validities, the same basic way that you would interrogate any other causal claim, or sorry, any other type of claim. So when you're interrogating causal claims, you're going to ask questions about each of those 4 types of validities. Why don't you take a second, pause the video, and give a verbal explanation out loud to yourself of what those 4 types of validity are and what each of them is assessing. So take a minute and do that. Okay, so you've got your understanding of those 4 big types of validity, right? Now let's talk about how we're going to ask questions about each of those when you're doing a causal claim. So one of those 4 types of validity is construct validity. We talked before about how construct validity is all about your variable measurement, right? We talked about this in measuring variables at length, how good was your operationalization, right? With causal claims specifically, you're going to ask questions about how well the DV was measured and how well the IV was manipulated. And you also ask questions about reliability, those 5 subtypes of construct validity, right? All those are still relevant here too. But in causal claims, you're going to add these questions about how well the DV was measured and how well the IV was manipulated. So for example, if I'm doing that feedback type and mood study and I decide to measure mood by observing whether a participant smiles when they're reading my feedback, that might not be great, right? Maybe you get negative feedback and you smile because you're like, what the hell? This is ridiculous, right? That might be a reason that you smile, but I would be coding a smile as happiness, but really it's not representing happiness at all, right? That would be a poor measurement of that DV. Whereas if I had asked people to self-report their mood, on a scale, that might have been more accurate. I wouldn't have miscategorized a smile as being happy because they would be self-reporting how they feel. So that might be a construct validity question you can ask, right? You can also ask how well was the IV manipulated. Say I'm doing a pasta bowl study and I give people a medium and a large bowl, but they're basically the same size. Maybe the medium bowl is just like a tiny, tiny bit smaller than the large bowl. In that case, it wouldn't be a great manipulation of bowl size because they'd be too similar to each other to really show me much of a difference at all. Compared to if I have one bowl that's, medium size and one bowl that's like really big, that would be a better manipulation. Now, remember, right, you can probably think as you're hearing me talk about this, there's no cutoff for a good DV measurement or a good IV manipulation. That's something that the researcher has to decide. That's that best judgment question, right? That's something that you have to assess. You have to use your critical thinking skills to think about, was this a good operationalization? Was this a good measurement? Was it a good manipulation? You have to decide that using your understanding, your knowledge of research methods. All right, now external validity, we talked about that in the previous module before the exam. So external validity is about generalization, right? Do your results generalize to other people and or situations? So you see on the slide here, that same question that we would ask of any type of study is relevant for causal claims. But one thing that's common with causal claims is that external validity gets sacrificed for better internal validity. We talked about this a while ago when we first started talking about the 4 validity types, that internal and external validity are typically in a trade-off. If you are prioritizing internal validity, as you are when you're doing an experimental study, that usually means you're sacrificing external validity. So something that you can ask about, excuse me, when you're interrogating a causal claim is whether that happened, whether you have better internal validity but you have poor external validity as a result. And we talked in the previous module about how if this is the case, right, we're in theory testing mode, we're trying to figure out, does the IV cause the DV? Once we have that nailed down in a couple of studies, then we can switch gears and look at whether those findings, that causal link, whether that replicates in different people and different situations. So we can switch from internal to external validity after we've got that theory testing mode down. All right, statistical validity then, again, this is something that's a little beyond the scope of this class, but with experiments, you're typically looking at differences between conditions or levels, like differences between the small bowl and the large bowl in pasta eating, differences between positive feedback and negative feedback on mood, right? So with statistical validity, you're asking, is the difference between conditions statistically significant? And if so, how large is the effect? Now that's something you'll talk more about in stats classes and in other classes in your major. So you don't have to worry too much about that right now, but just keep that in mind. You're looking at differences between conditions. Maybe you're doing a t-test or an ANOVA. If you've been in stats already, you know what that means. And you look to see how large is that effect. And then lastly, internal validity. That's the most important type of validity to ask about with causal claims, because the whole point of a causal claim is to make a cause and effect relationship. So you're trying to see, does the IV cause the DV? That's an internal validity question. So you would ask about things like, were there design confounds? Was there systematic variability, right? Like self-selection with the small bowl to the large bowl in the pasta example. Or only men in one condition, only women in another condition. Those are design confounds, right? You would also ask, were participants randomly assigned to prevent selection effects in an independent group's design? Or were the levels and conditions counterbalanced to prevent order effects in a within group's design? So those are all questions that you can ask about causal claims when you're interrogating them, when you're assessing the validity of your experimental study. All right, so again, right, internal validity is the most important for experiments, external validity is the least important, and construct and statistical validity are always important no matter what kind of claim you are having or you are testing. All right, now this slide is going to give you a little extra practice with this idea of interrogating causal claims. Starting with, I'm going to give you an example and a couple of questions, and you're going to think about which validity you think each question is asking about. It's not an activity for points, it's just a quick little check of your understanding. All right, so when you're reading the textbook for this module, you read about a study that looked at whether taking notes by hand or by laptop produces better understanding and memory for factual and conceptual knowledge. So I want you to think about which type of validity does each of the following questions about the note-taking study interrogate. So I have 4 examples of questions here. I'll read each of them to you, and then I'll have you pause the video, think about it, and then keep playing to hear answers. All right, so A, how large is the effect size between the laptop and the handwritten groups? B, how well did the essay test measure people's conceptual knowledge? C, were there any confounds in the experiment? And D, can we generalize from these college students to other types of people? All right, so pause the video and think about which type of validity you think each of these questions is interrogating. All right, so A, how large is the effect size? That's a statistical validity question. B, how well did the essay test measure people's conceptual knowledge? That's a construct validity question. How good is that variable measurement? C, were there any confounds in the experiment? That's an internal validity question. Is there a possible alternate explanation for the results? That's what a confound would be. And then D, can we generalize from these college students to other types of people? That's an external validity question. Generalization is always about external validity. All right. Okay, now one more little bit of practice here. Which of the following would be a critique of a study's internal validity rather than a different validity type? So which of these would be criticizing an internal validity? A, didn't use within groups design. B, didn't use random assignment. C, didn't use random sampling. Or D, didn't use a pre-test, post-test design. So pause the video, think about which of these 4 you think is a threat to internal validity, and then keep playing to hear the answer. All right, so the one of these 4 that would be criticizing internal validity, that would be B, didn't use random assignment. If you didn't use random assignment, like you allowed people to self-select medium or large bowl to eat pasta with, that would be a possible alternate explanation. All your pasta lovers would be in getting the large bowl, all the haters would be getting the medium bowl. That would be explaining the difference in the portion size, not the bowl, but the type of person who's eating the pasta with these different bowls. So internal validity threat, that would be systematic variability in that example. If you had randomly assigned, like the people in the study actually did, you get rid of that problem because all your pasta haters are evenly distributed across the 2 conditions. Same thing with your pasta lovers. So it's not personal characteristics like whether you like pasta that explains the findings. In that case, it would actually be bowl size, which is what you were trying to study in that particular experiment. These other ones here, within groups, random sampling, pretest, post-test, these are not internal validity questions. Within groups versus pretest, post-test design, that's not really a validity question. That's more about best judgment, about which design you think is going to be best to test your question. And then random sampling tests a different type of validity. Maybe you know what it is. Random sampling is a question about external validity. So how did you get your sample, right? Remember, external validity is how, not how many. How did you get your sample? That is a random sampling. That's what random sampling addresses. All right, now back in chapter 3, we talked about how many media journalists overstate correlational observational study results as being causal. It's a big problem. We talked about that a little earlier in these slides as well. What is the only type of study that can establish causation? It's an experimental design, right? That is the only thing that can establish causation. Correlational and observational designs cannot do that. We'll talk more about those in the next couple of weeks because they don't manipulate a variable. They don't have an IV and a DV. And so they can't account for things like temporal precedence. So experiments are the only type of study that can establish causation. All right, now which one of these headlines is representing a causal claim? A, parents give iPads to grumpy kids. B, having mom in the car makes teens safer drivers. And C, people who bet on basketball games enjoy watching them more. Take a minute, think about which one is a causal claim and how you know which one is a causal claim. All right, the one that's definitely a causal claim out of these three is B, having mom in the car makes teens safer drivers. The reason that's a causal claim is because of that word makes. We talked way at the beginning of the semester about how these strong causal verbs like makes or increases or causes, right? Those are indicating a causal claim. So this is saying that having mom in the car is making teens drive safer. A and C could potentially be causal claims, but they're kind of lacking those strong causal verbs that would say it definitely is a causal claim. So for any of these three, you'd actually have to take a look at the study design and see what did they do? Did they have an IV and a DV, right? Did they have some, so for example, for B, right, if you're trying to see if they really was an experiment that they're making this causal claim for, you would look and see in the study, did they have some conditions where mom was in the car with the teen and some conditions where mom was not in the car with the teen, and they assessed their driving quality, right? That would be the only way you could really support that causal claim. And same thing with these other ones too. Did they, for C, for example, did they randomly assign some people to bet on basketball games and some not to, and then measure their enjoyment? Maybe they did, but maybe they didn't, right? You don't know without looking at the actual study. So the idea here of bringing this back is this idea that, you know, causal claims require the most evidence to support them. We talked about that before, at the beginning of the semester. You have to have an IV and a DV. You have to have covariance and temporal precedence and internal validity. So it requires the most evidence to support a causal claim, but journalists often make the mistake of overstating a correlational study or an observational study as being causal. And that becomes a big problem because it's misleading the reader. All right, here's another bonus activity. Again, not worth points, but gives you a little extra practice. Again, if you complete this bonus activity, go ahead and email it to me. I'll give you feedback on your bonus activity. And then here's one more bonus activity. Again, not worth points. But again, if you would like a little more practice, you can go ahead and email me your response to this, and I will give you some feedback. All right, so that wraps up our discussion of experimental design for this week. So what is next? Homework number 15 is for next week's module. There's 2 parts in homework number 15. For this, you are reading 2 articles that talk about experimental design, that reports the results of experimental studies. There's 2 articles, but they're both pretty short. And I think they're both pretty interesting. So this first one, Darley and Latney, 1968, this is one of the very first studies that was looking at the bystander effect. So the bystander effect, you might know this from your other classes. That's the idea that the more people who are around when you're experiencing an emergency, actually the less likely anyone is to help, and that seems wrong. Seems like we should have safety in numbers, right? But turns out we don't. And you can read this article to see more about why that is. I think it's only like 5 pages long or so. So same idea as usual for this, couple questions about intro results, intro method results, discussion, and then a last question, a reflection. What did you find easy to understand? What would you like to discuss more? And then homework number 15, part 2. This is another paper that you're going to read. This is Loftus and Palmer from 1974. This study is actually about eyewitness testimony. So this is the idea that what you see might not be super accurate because a lot of things might get in the way of what you actually remember happening. So there's actually 2 studies in this paper. So you'll see number 2 and number 3 here, summarizing method, results, and discussion of experiment 1, and then method and results of experiment 2. This is our first multi-study paper that we're reading this semester. We'll talk more in next week's module about why there are multiple studies in this paper, what that means, what that does for the research question. And then, you know, again, question 5 here, looking at some reflection on what you're finding tricky or challenging or easy. All right, next week is online week 5 module. We're getting close to the end, you guys. Next week's module is kind of 2 parts. First, reading experiment articles. So that's what homework 15 was all about, which, by the way, is posted in next week's module already. Reading experiment articles, have you do a couple of activities about that. And then we'll also talk about correlational design in next week's module as well. All right, that brings us to our exit ticket for this week's module. So same as usual, clearest point, muddiest point. Please be sure in your exit ticket to let me know specifically if you'd like me to address your muddy point in a video, or if you are okay with just practicing a little more on your own. That's helpful to me when I make those exit ticket videos. All right, so you should be pretty much wrapping up the module now. You've done the 2 homeworks, you've submitted the activities. Now you're going to submit your exit ticket, and that will wrap it up for this week's module. All right, have a good rest of your week, you guys.